In this video, I'm going to try to do vibe coding in append-only mode. And the reason for exploring this is kind of twofold. If you've seen the previous video, you will have noticed that using Claude Code to do a proper data analysis in a Python notebook can be a bit of a hurtful experience. The main reason for this is that Claude doesn't have access to the data frames that live in memory, so it starts to play a guessing game, and especially because I like to use Marimo, it feels a lot safer to just use an LLM from within the notebook, such that I can always refer to a variable and then we can inject the schema of a data frame. Another aspect of this is that I do like to be in control. I do like to confirm that the LLM is doing the right thing, and doing it cell by cell does give me an opportunity to just inspect the data frame or a chart just to confirm that indeed we're doing the right thing. Working this way might result in more iterations, but it will also result in shorter feedback. So I am curious to see if this different style of doing vibe coding, doing one cell at a time from within a notebook, is going to be more productive. Now, a few rules. I'm going to be recording myself live when I do this. So when things go right or when things go wrong, you are going to see my response live. The only editing that I'm going to do is I'm going to cut out all the boring silent bits where I'm waiting for the LLM to give me a response. But the whole goal here is that I'm actually trying to do an analysis. I'm not here to make slop. I'm not here to do any sort of artificial hype or anything like that. I'm just here to explore a different way of vibe coding when it comes to doing data analysis in a notebook. And the hypothesis I want to confirm is this append-only one cell at a time style of vibe coding going to make me more productive? Okay, so I'm in the notebook again, and I'm just going to take a small moment to explain the data frame and the setup so far before actually adding some extra code. So this is the World of Warcraft dataset. We have a player ID. In this case, we're talking about a player that is a level 26 orc hunter, and at this point in time, this player is in Razorfen Crawl, which is a location on the World of Warcraft. One big aspect of this dataset is that there are a couple of bots in it. And you can use this datetime feature over here together with this player ID to add a session. And after that, we can try to figure out, hey, some of these users might have suspiciously long sessions, and those are probably bots, and then we have to filter them out before doing any research later. So at this point in the notebook, we have a function that can do the sessionization, so I can put a data frame in. I can set the threshold minutes for how much time is there allowed to be between two timestamps before I declare it to be a new session. If I were to scroll down, I also seem to have a clean data function. Oh, and I have a filter bots function over here as well. Okay, that's good. Then the next step that I want to do is I want to do some analyses of typical bot behavior. Like I'm kind of curious if bots are better at leveling up than maybe normal players. But before going there, I do want to mention that the setup is rather structured because I've turned all of these data processing steps into their own functions. And the nice thing about that is that allows me to apply a method chaining pattern, which you can see over here. Polars has a pipe method, and what that allows you to do is it allows you to start with a data frame, then we're going to apply the clean data function, and then we're going to apply the sessionize function, and then we're going to apply the filter bots function. And it really reads nice from left to right. We're going to take this thing, then we're going to do this thing, then we're going to do this thing. It's very readable, and it's also very nice to have a Lego brick kind of a feeling. I have a clean data Lego brick, then a sessionized Lego brick. If there's ever a bug, I know what function to look. And the way that I'm going to write the rest of the notebook now is to just make more of these functions and make some charts along the way to do an analysis. And the main feature that I'm going to be using to do all of my editing, by the way, is this cell-based LLM coding ability. So in Marimo, there are two things you could do. You could click this generate with AI button at the bottom, and then you can just type what you want that new cell to be. And in this case, what you can also do is you can refer to variables or data frames with the @ symbol, so I can do @data frame over here. So that's a thing that I could do. Another thing I can also do is I can go to an already existing cell, then hit Shift-Command-E, and then I'm able to, again, use an LLM, but in this case, I'm using it to edit this cell in place instead of adding a new one. So let's see how far we get with just vibe coding. Right now, we have a filter bots function that's going to remove players that have a bit of bot behavior. I think in this case, because I want to aggregate on it later, I want to make an edit. Let's change this function. Instead of filtering, I want to add a column that declares if a user is a bot or not. And let's see what it makes of this. Okay, we get a nice little diff. Instead of doing the filter here, it's doing a with columns. It's going to calculate the maximum session length. That feels fine. And then afterwards, it's saying is bot. And then we're going to check if you're over the max limit. That feels pretty okay. Yeah, actually, so this totally reads fine in my book. So I'm just going to go ahead and hit play over here. And when I do, I can go to this new column. This pipeline is going to get an update, and you're going to see that I have a session ID, and I have a flag for whether or not that user is a bot. So from here, I should be able to do all sorts of interesting aggregations. What I'm just going to go ahead and do is call this df feet to indicate that this is a data frame with more features attached. Cool, so that's now attached as a variable, and that means that I should be able to refer to it when I make a new cell, which I'm going to do below. So I can do at data frame with features, and let me also zoom in a smidge. And I'm going to type a bunch of text now, so I'm going to use Mac Whisper to record my voice, and then my voice is going to be injected here. I want to make a function that is able to accept that data frame. And I want to do some aggregations to understand how bots might be different from other users. One thing that I'm particularly interested in is how fast players are leveling up. I want to know if bots are maybe quicker or slower. To calculate this, let's make sure that we keep the player class in mind. If I remember correctly from my teenage years, hunters are easier to level up than warriors. It might also be the case that the speed at which you level up depends on the month that you're in, because World of Warcraft does have a few new patches that are being released. And I'm going to type the next bit. Let's have one function add level feats. I want that one to be all about the features about how fast you're leveling up. And another one that can do a aggregation based on the bot attribute. And let's call that function aggbot. Okay, so that's a whole bunch of text. I personally really like it to be verbose in this phase because it tends to lead to less issues later. And at this point, I'm just kind of curious what it makes of it. So I'm just going to go ahead and hit enter now. It's going to take a moment because it's generating. Note, by the way, I'm using Claude for Opus on this one. And it's made a new cell with the two functions that I want. The way it's applying a transformation here at the bottom, I can do that by hand. That's not the way I want it, but I'm going to go ahead and hit accept now, because this does look relatively promising. So at first, we're doing a whole bunch of effort to calculate the year month. In order to calculate that, we don't have to sort by player and date time just yet. After that, we are calculating the level diff and the time diff. Okay. It's not keeping the session into account here, though. And I think that that's an issue because without the session, this time diff is going to be all over the place. And you need to do more than just sorting over the player ID and date time. Yeah, so okay, I'm going to have to ask it to fix that. That's a shame. And let's not even look at the aggbot stuff. This has to be fixed. So Shift-Command-E. Let's fix the add level feats function at if feat goes in, and it has a session ID, which needs to be taken into account. Or hang on, you could do it differently too. You don't need the session ID. What you could also do is maybe do more of a group by on the level and then just count how much time that took per player per level. But yeah, maybe it's first good to point out what's wrong with this implementation, because that still holds. If it goes in, and when we calculate the time difference, are ignoring different users. Instead, how about we aggregate or partition by the player ID and the level? We can just keep track of how much time was spent per level. And one thing I shouldn't forget, when we do this, we should also keep the month of the year in mind. Or actually, do we? Actually, and I think we don't even have to keep the month in mind at this point. If we just have this, then after the fact, we can also just aggregate on the month. So let's just do this. Okay, so I've zoomed out now. Now, one thing that's really nice about doing this in-place edit is that as you make the edit, the old prompt sticks around. It's not that you're generating a cell and then you're done with it. No, if we don't like what we see over here, then we can just change the prompt and tell the LLM to do it again. So let's see what it does now. It's doing a group by over the player ID and the level. I was assuming it was going to use the with columns and then over, but if you're doing a straight up group by, yeah, then I think this is pretty good, but I think I want to have the year month be in this group by, but the rest looks pretty good. Okay, so I'm going to hit accept. And then I'm just going to do this one manual change. I'm going to add year month in this group by, and then it can go away over here. Yeah, I'm still a little bit on the fence about that, but at this point I just want to inspect and see what it does. So I'm going to basically just ignore the bot thing, df level features. Let's just run this. And then we have aggregated everything on this one player ID level, and I guess we added year month. And then we can see how much time was spent at a specific level. So for every single level, we know, okay, Here's a user at level 80. That is the max level now that I think of it. So it makes sense that for the max level, we see time spent at level to be super high. Okay, yeah, so that's interesting. And I guess at this point, there's a start time, there's an end time. I don't need to aggregate by year, month now that I think of it. Yeah, so I don't need to do that. So I guess that looks fine. I do want to make some charts in a bit, but I am going to do this aggregate bot call at the end over here. Just pipe that through. Oh, and that's actually kind of interesting. If I just look at the Druid, for example, if you are not a bot, then you spend about 400 hours per level. Actually, no, hang on. There's a few things that are going awry here. As we saw before, the max level, that's the final level that you're going to be at. If you're going to be playing around a lot at that final level, that says nothing about your leveling speed. So I actually want to make sure that those rows are gone here. So yeah, I need to investigate that a bit more in depth because the leveling speed should only be determined by the non-max levels, if that makes sense. So, okay, I need to do a bit of a deep dive. And maybe the fastest way to do that, just inline right now, I'm just going to say filter. And let's just take the column max level. And let's just say that that is underscore in. There we go. So we can say that is not allowed to be in level 60, level 70, or in level 80. Those are, I think, depending on the expansion pack, those are the max levels that you have. Again, it could be that that's the max level and you keep on playing in it. That's going to heavily skew the average hours per level statistic that I'm interested in. So let's just make sure that we avoid those. And I guess, is that a tilde in this case, if you want to negate it? Okay, good. I can see the max level is no longer 80 now, so tilde is indeed negation for those expressions. That's good. Let's sort by class, descending. Cool, and then we should be able to make a bit of a comparison. Okay, the difference is actually more striking now. That is interesting. So it actually looks like players that demonstrate bot behavior, or at least the current definition of it, they tend to spend way less time. Yeah, is bot is true. Yeah, so the bots seem to be way better at leveling up than the non-bots, and it is a substantial difference sometimes. It does depend on the class, though. Although, you know, kind of have to be careful with this. We also added the player count over here, right? And these bots over here, they are like relatively small numbers compared to the big player counts. You know, it's not like n is equal to 1 or anything, but if one bucket is n is equal to 16 and the other bucket is 4,000, you know, fair difference. But yeah, that is pretty interesting. And I think what I can also do now is maybe also just group by the level. Then I don't need the max level anymore. Right, and then this starts to feel like a data frame that I might want to have a visual for. The visual I want to have in my mind, right? And usually it's a good exercise to draw it out before you write any code. But let's say on the x-axis over here, I've got the level. And here I've got the level time. And then I'm just interested to see, you know, maybe I've got a blue line over here for a druid. And then maybe a dotted line under it for like a druid, but a bot. I don't know if we have enough data for that, actually. Alternatively, maybe we don't do it per class. We just do not bot and bot. Yeah, let's do that one first. But it kind of feels like I'm just interested in the distribution over the level. So let's see if we can generate that one with an LLM. And what I'm just going to go ahead and do is I'm just going to make a new cell over here. And then I'm going to do Shift-Command-E to get this prompt in here. And it's mainly because right now the UI allows me to reuse that prompt if I see something going bad. But yeah, to do that, the first thing I got to do is call this data frame stats, I guess. Because then we have this in a variable. Then I can refer to it down below over here. So I can just like at df stats. And let's use voice mode. I want to make a chart where on the x-axis you've got the level, and on the y-axis you've got the time that it took to level up. You may need to do a little bit of aggregation beforehand. Make sure you use polars and altair for that. Let's run this. Okay, so it looks pretty good. I'm gonna hit accept now, and let's just run this. Okay, so average time to level up by class and bot status. And okay, it's doing a whole lot. It's doing too much, actually. So let's just not do the stroke dash thing. I don't think I'm interested in the isBot stuff. Let's also just ignore the tooltip for now. Oh, that's interesting. It's quite spiky. It goes up and then it goes down again. Huh, okay. That's interesting. Let's have the color depend on isBot for now and just ignore the classes. Oh, right. There's a lot of spiky behavior right now because that spikiness is determined by the class name, I think. So that kind of works. The chart has a bunch of spikes, and the reason for it is that we have a data frame that still has a aggregation per class. Let's remove that aggregation before we make the chart. There we go. It is now doing a group by isBot and level. It's going to sort by that. That looks fine. Okay, that is interesting. So the blue line is that you're not a bot, and then the orange line is that you are a bot. And in general, I mean, the early levels are maybe outliers, but it does seem that in general, bots indeed do level up a whole bunch quicker. But oh, no. Okay, something went terribly wrong here, actually. Feel free to pause the video, because I think you can see the mistake actually that's taking place here, but I need to really slow down now and look back at the code that was generated, because something is not adding up here. Let's slow down. The chart that I've got here, we've got level on the x-axis, and then we've got average hour per level, and I'm about to apply a little bit of domain knowledge when it comes to video games, but this chart must be wrong. Normally, in a video game, you level up quite quickly early on, and then as you progress, then typically it takes longer and longer and longer, and sure, whenever there's like expansion packs, some things might be different, but the shape of this chart is just not making any sense. I would expect a chart that definitely looks a little bit more like this. So we've made a mistake somewhere, and if I had to guess, I think I made a mistake personally as well. We definitely have to keep this session in mind, because I think what we're doing, remember how we're calculating a duration? I think what we did is we did something like, hey, take the level, then take the minimum timestamp, take the maximum one, and then look at the difference between the two to figure out the duration. But there's multiple sessions in there probably. And what I could do is I could maybe count the number of rows, because every row represents 10 minutes. So yeah, you don't need a session ID in order to calculate what's needed, but you cannot use the timestamp. You have to count the number of rows and then turn that into a duration instead. So now before I start fixing this, I do want to make a pretty big meta observation, and that is that, oh my, I need charts like this to debug what is going on. Without charts, all this stuff will be way harder. And although this is a massive mistake and I should have caught it earlier, right? Like, I don't want to deny that. I was going too fast. That's why this thing happened here. I definitely could have caught this earlier, but I still think this way of working with an LLM, append-only mode, and then make plenty of charts as you go along, that does give you a great opportunity to doubt your pipeline, and that does also force you to re-inspect your code whenever you see a chart where something is going awry. And the big risk when you're doing stuff like this is that oh, there's speed and I want to go fast. And maybe what you want to do is definitely use the LLM, but then to take it slowly and smoothly. Anyway, let's just fix this thing first. So I'm going to scroll up. So I'm back up now. This is the add level features function where we do the player ID level group by. There's the min and the max of the date time. And then there's the time spent at level. And there you go. It is literally using the level end time and the level start time. And what I think I wanted to do instead, let's take that observations at level thing. Every row is about 10 minutes. So let's multiply that by 10. And actually, I think we can make do without this one with columns block over here. Because what I can also just do is just do minutes per level equals. Then I don't need this alias. We're going to filter per hours per level. We also don't need that. Oh my, I should have done a better review of this code. Okay, let's just delete that. Okay, so we're using minutes per level here. Let's double check if we're using that here too. Oh, we're not. We're using hours per level here. Okay, let's go for hours per level because that's what the aggregation function afterwards expects. And then instead of multiplying by 10, we divide by 6. Because it's every 10 minutes. If we have 6 of them, we have 1 hour. Let's just check if we didn't make a mistake. If we close all the brackets, that function looks good. Okay, let's try it. Okay, so I had to fix a typo. There's also a couple of dirty classes in here. I do want to fix that, but I mainly care about the chart but down below. Yeah, okay, that definitely looks different now. So I would argue that's a good thing. We do now see massive spikes around level 60, 70, and 80. So you know what? Let's actually put that filter in here manually because that'll hopefully make the chart look a bit better. Okay, yeah, this chart definitely looks not only different, the conclusion also looks a bit different. That is also very interesting. Okay, let me do a quick cleanup first because there's a couple of classes in here that I don't like, and then I'm going to spend a lot of time figuring out if I like this chart or if there's maybe another mistake in it. But it definitely looks different. So yeah, okay, we did fix a thing just now. Okay, so if I do a quick group by over here, then there are a couple of classes indeed that I don't want to have around. So, okay, the clean data function will now also have a allowed classes list. Okay, cool. I was able to autocomplete that as well. So Paladin is in there, Death Knight is in there, Shaman is in there, Priest. Okay, they're all in here. So that was a minor bit of data cleaning, but I'm still happy that I did it. Now the one thing that I want to do is I just want to add interactive here, because that way I can also zoom in and I can kind of see what's happening here. So apparently at level 1, there's a lot of bots just spending a lot of time. And that kind of makes sense. Like if you're a bot account, you might be doing some tomfoolery. So okay, that feels plausible. But after that, it definitely seems that the time per level for a bot is actually higher. Another thing that's interesting to just kind of have a look at here is notice how all the way up until level 60, although there is a bit of a click down here, like it seems to be going up, it seems to take more time, but then once we reach over level 70, then it starts going down, and it feels like it's kind of against the pattern. I happen to know this dataset quite well, so I know what's happening here. And this will be like a hard thing to know or even figure out if you don't know the dataset. So World of Warcraft, the video game, has these expansion packs. And when an expansion pack is released, then a whole bunch of new levels get added. So before, level 60 was the highest attainable level, then level 70. So everything that you see happen here, that's like the first expansion pack, basically. But at some point, the second expansion pack got released, and I think around the time, they also made the decision that the end game of World of Warcraft is more important than everything before. So they made leveling up just way quicker. And that is also interesting because you can see that basically just the leveling speed just really increases. Like the average hour per level just, plummets. I guess I want to make a second chart now though. So this chart is useful, but instead of having a chart with the level on the x-axis, I kind of now want to have the month year, if that makes sense. Now I have to think a little bit about this because I think I want to have a different visualization. Right now we're showing the level, and that's useful, but this dilutes the over time aspect of what we're seeing here. So maybe if I were to sort of come up with a different chart, I kind of want to have month, year or something like that. Like I want to have time and probably bucketing that feels on the safe side. And what do I want to have on the x-axis? Well, I kind of want to have like leveling speed of sorts. And I could take the average of all the levels. I could also do like a weighted average. That's also something I could do. But then what I'm expecting is that like in the beginning, it probably took more time to level up. And then hopefully we should see around the time that there's an expansion pack that this kind of goes down. And I'm also kind of, and yeah, it feels I want to have that line just to confirm my hypothesis, my domain knowledge. And yeah, we can still do this aggregation about whether or not you are a bot kind of a thing. Another thing that might also be cool is to see if we can make a line like this per class. Like some classes might actually be easier to level up, so to say. So that could also be a fun exercise. But yeah, the classes are like an okay thing to know. The main thing I'm interested in knowing is just this month-year thing. And you know what? I'm just gonna go with a simple average for now. But let's make a new cell below for that chart. So I'm going to use the mic again. The prompt is I want to make another chart with that data frame. This time around though, I want the x-axis to be the year month, but we have to make sure that it's of type date time because otherwise the plot is not going to render nicely. Make sure that aggregation happens beforehand. And on the y-axis, I think I want to have some sort of a average leveling up speed, but we should normalize this per level in some way. Okay, so hopefully that's enough context. Let's have it render. It's come up with something, and it's made a chart. It looks kind of all right, but one thing that I've learned from before is that I'm not going to take this chart at face value. I just want to really look at the code first, and in this case, the main thing is just kind of bothering me. I mean, it's doing the datetime conversion. That's cool, but it is doing this hours per level, levels per hours thing, and this is not normalized for the levels, so I'm going to prompt it again. The way that you're calculating the levels per hour here makes sense, but some levels just take a fair bit longer than other levels, and it does feel like we have to normalize for that. In my mind, I'm thinking one thing we could do is we could just kind of bucket it and then not use a line chart, but just a sort of a chart with lots of squares in it, where the color of the square indicates how long it takes. But I'm kind of curious what it just does with this. You can normalize this, just seeing if it's clever enough to do that. Okay, that's a fair way of doing it. It's first going to calculate the baseline hours, as in what are the hours per level across the entire data set, and then it's going to compare the speed. Okay, so eventually we end up with a chart that looks a little bit like this. And it definitely seems like November 2008, that's when the speed at which you can level up does increase. And let me double check. Yeah, the Google AI overview can confirm that November 13th, Wrath of the Lich King came out. Okay, so that's a nice thing to kind of confirm. The one thing I don't necessarily like about this chart, though, is that you do get this hard to explain metric on the y-axis. I guess one thing that is nice is you can claim that the leveling speed increased by a factor of 5 on average, and it's actually the bots that are kind of lagging behind on that one, so that's interesting. It does seem, however, that the leveling speed goes up here as well, although you might wonder if that's due to a expansion pack. It feels a little bit more gradual in this phase, so it might just also be that there are better guides and people are better at leveling up. There's more guilds, more people helping each other out, so that might be what's happening there. As a way to make it a bit more interpretable, like one thing you could also do is just say, look, here's the first 3 months, maybe normalize based on that. That's not going to be perfect either, because when there's a new expansion pack, you're going to get those new levels, so then you have to have a different norm for a different year, because that's the point where we have different levels. Actually, let's actually do that as a final step. Let's just only look at the first 60 levels, actually. That might be a sensible thing to do. So both the baseline hours and for the monthly speed thing we're doing over here, let's just make sure we're below level 60. Okay, and when we do that, the chart still kind of has the same shape. So, okay, there's definitely an effect of leveling speed with regards to expansion packs. Oh, another thing that's interesting, it seems that this line for whether or not you're a bot, that seems to evaporate if we remove all characters above level 60. So that's also like an interesting thing to dive into. The main thing I wanted to discover in this video is if this append-only mode is a meaningful way to do work with an LLM in a notebook, and I gotta say, for me, the answer is yes. The only risk is that you might still get this dopamine hit from like, oh, more code, and that you're gonna go too fast. Whenever you're generating a chart, that'd be an excellent point in time to just take it slow and to see if there's anything unexpected or wrong with it. Because in this video, even though I knew the dataset quite well, I also almost made a mistake, and I was only able to spot that because I was slowing down and actually took the time to look at the chart. But anyway, conclusion, append-only vibe coding, very good, because you can make these charts. These charts help you debug, and you don't have unit tests when you're working with a data set, so this definitely feels like a good way to work. Vibe coding from a terminal, generating lots of files, there's a place for that, but that might be more web dev. If you're doing things with data, you need interactivity, you need the charts, which is totally help. So the append-only mindset, don't go too fast, and if you do that, I think you'll have a good time.